It's time to solve a radical equation. Notice we've got double trouble. It'll be a lot of work. Let's begin by isolating one of those radicals. Move this radical to the other side using addition. We have the square root of 5x minus 1 is equal to 1 plus the square root of 3x take away 2. Now that a radical is isolated, undo it. Square it. But when you do, square both sides. When we square a square root, they cancel out. On the other side, you have square of a binomial. That means two factors. Write it twice. You might remember to use FOIL. When we do use FOIL, we multiply our first, the outers, and the inners. The outers make one of these radicals. The inners make another one of those radicals. The last, you've got a square root times a square root, the same number inside radicand happening 2 times. You're going to be able to take out a 3x minus 2. Let's clean it up. We've got a like term here and another like term there. When we do combine our like terms, we see 2 of these radicals and a 3x minus 2 at the back. Okay, if we're going to solve this radical equation, we have to get the next radical all by itself. Let's combine our like terms. We've got a 1 and a negative 2. That gives us a negative 1 plus 2 square roots of 3x minus 2 plus 3x. When we isolate this radical, we do so moving 1 to the other side with addition. And we can move 3x to the other side with subtraction. Notice that we line up our like terms. These cancel. We intend for those to cancel, but look, here's a surprise. We still have 2x is equal to 2 times the square root. Now the radical is mostly alone. You can continue to isolate the radical or not. We could undo that radical if we square both sides. Let's square the left-hand side. Let's square the right-hand side. 2x times 2x makes 4x squared. 2 squared is 4. When you square a square root, you set that 3x minus 2 free, but that 4 will be multiplied by the 3x and the minus 2. Okay, it appears that we will find 2 solutions. Let us distribute. Four times 3x gives us 12x. 4 times negative 2 is negative 8. To get those 2 answers, we need a 0 on one side. We'll move 12x to the other side with subtraction. Move 8 to the other side with addition. Let's solve by factoring. There is a GCF. Take out that greatest common factor of 4. You're left with x squared. 12 divided by 4 is 3. 8 divided by 4 is 2. We can continue to factor. For this trinomial, our signs will be the same. They will both be negative. The factors of 2 that add to make 3 are 2 and 1. And now it's time to set our factors equal to 0 and solve. But saying 4 equals 0 doesn't make any sense. X take away 2 equals 0. X take away 1 is 0. Our answers are 2 and 1. But beware extraneous solutions. We have to check our answers. We check them by plugging them into the original statement. When we check the first one, 5 times 2, take away 1 inside a square root, minus the square root, 3 times 2, take away 2, inside a square root. Is it really going to make 1? Well, that's the square root of 10 minus 1, or the square root of 9. The square root of 6 take away 2, or the square root of 4. Well, that is 3. Take away 2. Yeah, that's 1. So the first answer does check out. It really is an answer. Let's check the next one. The same way. We've got 5 times 1. Take away 1 inside a square root. Minus 3 times 1. Take away 2 inside a square root. Is it really going to give us 1? That's the square root of 5 minus 1, or 4. Take away the square root of 3 minus 2, which is 1. Well, 2. Take away 1. Yep, this one checks out also. So we can conclude that both x equals 2 and x equals 1 are solutions.